All right, let's talk about the absolute pinnacle of automotive engineering. We're going beyond just speed to get into what really makes the most advanced cars on the planet tick. We're talking about the incredible science that lets supercars practically defy the laws of physics.
So what's the secret sauce? What really separates a normal car from a machine that can blow past 300 kilometers per hour without breaking a sweat? What is it that makes a supercar, well, super?
Now, if you're thinking a giant engine, you're not wrong, but that's just one piece of a much, much bigger puzzle. The real story is this amazing dance between science and engineering, all working together to solve some seriously extreme challenges.
So let's get on the same page here. A supercar isn't just a fast car. It's a purpose-built solution, designed from the ground up to handle the insane forces you experience at high speed, and it does it with a whole suite of incredible technologies.
This brings us to the first major hurdle, the battle against physics itself. To go that fast, engineers have to outsmart two main opponents, the very air the car is pushing through and the car's own weight. You know, we don't really think of air as being a big deal, right? But when you're moving at 300 kilometers an hour, that air might as well be a wall of invisible bricks. Air resistance becomes the #1 thing the car has to fight against. But here's the brilliant part. The best engineers don't just fight the air. They turn it into a powerful friend. It all starts up front with the splitter, which directs air under the car. The sleek body shape keeps that airflow smooth. But the real magic happens out back. That giant wing works like an upside-down airplane wing, literally pushing the car down onto the road. And underneath, the diffuser creates a low-pressure area that sucks the car to the ground. That's downforce, and it's the secret to staying planted at incredible speeds.
Okay, so you've managed to slice through the air. What's next? Well, now you have to deal with the car's own inertia, its weight. Every single kilogram is something the engine has to move, the brakes have to stop, and the tires have to turn. When it comes to performance, weight is public enemy #1. And the rewards for cutting weight are just huge. I mean, think about it. A lighter car doesn't just accelerate faster. It stops quicker, it turns sharper, and it's even more efficient. It's a win-win-win. So how do they get these cars so light? They put them on a serious diet of exotic, space-age materials. Carbon fiber is the star of the show here. It's unbelievably strong but weighs next to nothing. Then you mix in things like special aluminum alloys and titanium, and you can build a chassis that's super rigid and safe, but also incredibly lightweight. All right, we have a lightweight, aerodynamic body. Now what? Power. Lots and lots of power. We got to talk about the heart of the beast, and just as crucial, how you get all that force to the ground without just spinning the tires into smoke.
Right now, there are kind of two main paths to creating that power. You've got your traditional supercars with these wild, high-revving combustion engines, often with turbos, that just scream as they build power. But the new kids on the block are the electric ones. Their motors give you 100% of their power the exact instant you touch the accelerator.
And the result of that instant power, it is just mind-bending. We're talking 0 to 100 kilometers an hour in under 3 seconds. That is violent, brutal acceleration that's only possible because of how electric motors deliver their power.
Which, of course, brings up a super important question. It's one thing to have 1,000 horsepower. It's a completely different challenge to actually make it usable, to keep the car from just becoming an uncontrollable rocket.
And the answer isn't just one thing. It's a whole system working in perfect harmony. You've got active suspension that's reading the road and making adjustments hundreds of times a second. The tires are super wide and made of a soft, sticky rubber compound for maximum grip. The brakes? They're huge carbon ceramic discs that can handle insane temperatures. And the whole car is designed to be as low to the ground as possible for ultimate stability. But even with all of that incredible hardware, there's an invisible layer of genius making it all work. Let's pull back the curtain on the car's hidden brain and see how these machines can actually endure the forces they generate. Just to put this in perspective, the computers on board these cars are processing information at a staggering rate. There's a whole network of sensors making thousands of calculations every single second just to keep tabs on what the car is doing. So what's this hidden brain actually doing? Well, everything. It's running the traction control to stop the wheels from spinning. It's doing something called torque vectoring, sending power to specific wheels to help you turn sharper. It's even adjusting the wings and flaps in real time. All this software is working together to keep the car right on the knife's edge of performance.
But there's one nasty side effect to all this speed and power. Heat. Just immense, overwhelming amounts of it. The engine, the batteries, the brakes, everything gets incredibly hot. Hot enough to destroy normal car parts.
And that's why managing heat is such a huge deal. You know those massive vents and scoops you see on supercars? They're not just for looks. They're grabbing enormous amounts of cool air and feeding it to a complex system of radiators and liquid coolers, all designed to pull heat away from critical parts so the car can perform lap after lap.
So when you put all these pieces of the puzzle together, you start to see the big picture. A supercar isn't just a collection of fancy parts. It's a completely unified system, a true engineering masterpiece.
So this is the formula. It's mastering physics, using advanced materials, creating incredible power, and then orchestrating the whole thing with brilliant software. Every single part depends on the others. You take one piece away, and the whole thing just doesn't work at this level.
Really, the best way to think about these cars is that they aren't just cars at all. They're moving laboratories. They're the cutting edge, constantly pushing the boundaries of technology and what's even possible.
Which leaves us with one last awesome thought to chew on. As engineers continue to master aerodynamics, materials, and power, what's the next great challenge? What's the next physical barrier that human ingenuity is going to find a way to smash through?